Okay, so hello and welcome to this video tutorial for E411, Statics and Dynamics of Simple Mechanisms. So we have this problem here, determine the force in each chord for equilibrium of the 200 kilogram crate. Chord BC remains horizontal due to the roller at C, and AB has a length of 1.5 meters, Y is 0.75 meters. Okay, so as you might typically do for a problem like this, let's start by drawing a free body diagram. So we have this. Oh, that is the worst straight line I've seen in my life. Let's have another go at that. Right, we have this. We have the tension in CB acting here. We have the tension in BA acting here. And we have this, the weight of this 200 kilogram crate here. Let's label it 200G. I trust that you guys are familiar with this idea of G, where G is equal to 9.8 meters per second squared. And let's label it my BA. Wonderful. Let's consider the geometry of this problem. So from here to here, you have a, almost. You have this length of 2 meters, and from here to here, you have this length of 0.75, and from here, how shall I draw this? From here to here, you've got this length of 1.5 meters. Okay. I think that's all the information I need. So how might I tackle this? Well, the problem mentions that this is in equilibrium. Since it's in equilibrium, we can introduce this idea that the sum of the forces in the x and the sum of the forces in the y are equal to 0. So let's start by resolving horizontally. The forces acting horizontally here are this CB force and the horizontal component of this BA force. In order to express the horizontal component of this BA force, I'm probably going to need the angle that this force has with the horizontal. So it's probably going to involve some trigonometry, right? This 1.5 meters I can treat as my hypotenuse. This 0.75 I can treat as my opposite and hypotenuse. Well, that sounds like we need sine, where sine of an angle is equal to the opposite over the hypotenuse. If I take the inverse sine of both sides here, then that leaves me with the angle being equal to the inverse sine of the opposite over the hypotenuse. The opposite is 0.75, the hypotenuse is 1.5, so let's just write this all in. And when I type that into my calculator, I get 30 degrees. 30 degrees. So let's add that to my diagram, because why not? Let's draw the horizontal here. And that says 30. Believe it or not. So I think we have everything we need to resolve horizontally now. So let's consider things acting to the right. We've got this horizontal component of BA, which we can say is BA cos 30, and we've got this CB acting to the left. I could write it out like this. I could say minus CB equals 0, but I'm going to kind of skip a step here. I'm going to just say that the horizontal component of BA is equal to CB. Okay, let's resolve vertically then. So things acting up, I've got the vertical component of BA. BA sine 30. And acting down, I've got this 200G weight here. So I can say that BA sine 30 is equal to 200G. Now, I should have mentioned earlier that when we resolved horizontally, we found that we determined an equation that in its own right is not solvable because there are two unknowns in it. But when we resolve vertically, we determined an equation that only has one unknown in it. So this equation here is solvable in its own right. We can just rearrange. So we can say that BA is my handwriting. BA is equal to 200G over sine 30. I really have to focus sometimes when I'm writing. So 200 times 9.8 all over sine 30 is equal to 3,920. Let's put the newtons in there. And I have BA now. I can just solve for CB with this first equation here. I can say that CB equals 3,920 cos 30. Let's just separate these things, which is equal to 3,920 cos 30, 3,395. 3,395 newtons. Bam. Okay. Let's just double check the problem and see if I've got everything I need. Determine the force in each chord for equilibrium. Yeah, fantastic. So I've got the force in BA, it's 3,920. I've got the tension in CB, it's 3,395. So if you have any questions about that problem, feel free to leave them in the comments. And thank you very much for watching.